Hello out there in internet world. This is a quick summary video to talk about some of the algebraic techniques for finding the slope of a tangent line using first principles. A lot of the theory has been discussed prior to this video, but for here I just wanted to focus specifically on the algebraic technique. So first of all, just a quick overview of what we're doing. We're trying to find the slope of a line tangent to the curve y equals 3 over x plus 1 when x equals 2. I'm going to go to my technology and get a graph so that I can get a sense of what the question is asking geometrically. So I'm actually looking for the slope of this red line because this is where when x equals 2, we meet the curve at the point 2, 1, and we are tangent to the curve. So my objective is to find f prime of 2, which f prime of 2 means slope of this line. I set up my derivative using my definition. The limit is important to include there all the time, and then this is just the startup, and then I substitute in to x the 2 plus h and the 2 to get this result. Then I just clean up the denominators, and I get to this point where I am supposed to figure out what to do with 3 over 3 plus h minus 1. How do I divide this h out if I can't figure out what's in here? Well, in order to do this, I have a fraction, subtract 1. Anytime I have to add or subtract fractions, I need a common denominator. So the denominator here is 3 plus h, so I multiply top and bottom by 3 plus h. Oops. In so doing, I have 3 over 3 plus h minus 1 times 3 plus h over 3 plus h. Notice I have subtraction of the numerator all over the common denominator. And then 3 minus 3 is 0, and don't forget to distribute the negative there. That's a big deal. So we're going to get negative h over 3 plus h times 1 over h. The h's divide out, and so at this point, now that I got the h out of that denominator, I can basically just allow h to approach 0 here, and I would find negative 1/3 as my slope, which is consistent with the graph. We can see down 1 over 3 puts me right back on the line. So the brief summary here is when working with rational functions and using first principles to find the slope of a tangent line at a point, we're just going to find a common denominator algebraically, and you're going to multiply the second number by top and bottom by that common denominator, and everything is going to clean up real nice if you do that correctly. Okay, the next piece is when we have, you can also, by the way, check this with Desmos. It's a really clean algorithm to get it all squared away, and it shows that f prime of a, which is at 2, is negative 1/3, so it's good. All right, so here it says find the slope of the line tangent to the curve. F of x equals square root of x plus 2 at x equals 2. Once again, a quick little graph. The setup is all the same, so that's nothing surprising. It's right here where I get stuck because I can't get the h out of the denominator because the other h that I would divide with is trapped under the square root. So I need this square root to go away. Squaring top and bottom isn't going to help, besides the fact that if you square a fraction, it's no longer equal to itself. It's now a squared version of itself. So that's not going to work, but what I can do is multiply the top and bottom by the same number. In this case, I choose square root of 4 plus h plus 2 to be multiplied by the square root of 4 plus h minus 2. This is what we know in math as conjugates. These are conjugate pairs. As a reminder, when you multiply conjugate pairs, square root of x plus 3 times the square root of x minus 3, for example, the square root of x times the square root of x gives you square root of x squared, negative 3 times the square root of x, positive 3 times the square root of x, and 3 times negative 3, which is negative 9. Well, the square root of x squared is fine. 9 is really 3 squared. And then the middle terms, negative 3x and positive 3x, they subtract out to 0. So the net effect of multiplying conjugate pairs is that you can square the first term and square the second term and subtract those two, and that will be the resultant product. The objective is no more radicals. So by multiplying top and bottom by a conjugate pair, we end up with an expression that has no more square roots in it, and that's a good objective. So conjugate pairs is the key. It makes the middle terms drop out, and we just end up with the difference of squares of the original two terms. So that's what I'm going to do here. The square of the square root of 4 plus h is 4 plus h, and the square of 2 is 4. And then the h and the 4 plus h plus 2 square rooted thingy, that all has to stay in the denominator. Just leave it be, don't have to distribute, because in the next step, I'm going to divide the h's out. Now that I've done that, I can allow h to approach 0, and we get 1/4, which is consistent with my graph, and everything's good. So the key here, conjugate pairs when working with radicals, and the key here is common denominators when working with fractions. So I hope you find this helpful. Have yourselves a great day.